Hey everybody, welcome to Mammoth Interactive's YouTube channel. First of all, I want to thank you for watching this video. And remember that this channel doesn't do Patreon. Instead, we sell our digital courses down below. And every single dollar that we get from the products you buy below goes into making more content. The best way to help out this channel and Mammoth Interactive is to subscribe to Mammoth Interactive's huge library of content. Get thousands of hours and hundreds of courses for a low price down below. We have a monthly option and a yearly option. Thanks for listening, and I'll see you in the video.
The first thing that we have to do before working on a new game is to make a new project. In Unity and in several other game engines, every game is going to be in a separate project, so there's going to be a folder just for that. It's going to store all the necessary files, all the plugins that you're going to import, all the models, scripts, and things like this. So when you open Unity, you can find this new button in the top right of the window, or there should be a button in the middle as well called Create New Project. And once you click, you're going to be taken to this screen. We have to set a few things here. First of all, we need to set the project name. So I'm going to name this Adventure. And then we have the location of the project. It's very common for beginners to just drop the project whatever they want, so they use the desktop folder, the documents, even the downloads folder. But I highly recommend you to make a folder just for storing your projects, even if it's your first time making a game, you don't know if you're going to make more, make a projects folder. If you look here at the location, it's already set to users / my username / projects. So every game that I make is going to be a folder inside the projects folder. This is going to make the difference later. Then we have to set the rendering mode for the game. We have 3D and we have 2D, but we're going to leave the first option active, as this is going to be a third-dimensional game. We have a button that says Add Asset Package, but we don't have to worry about this right now. Okay, this is just if you want to use some things that already come with Unity, like a package for cameras, characters, for vehicles, for example, but there's no need to add any of those. And after we are done setting these things, we have to just click Create Project and wait for Unity to open. Okay. So it's just a very basic setup, just to make sure everything is going to be okay, it's going to be organized. We're going to be in the default layout for Unity, okay, just as it comes out of the box. And with this in mind, we're going to move on to the next lesson to start making this game. There are several ways to start making a game. We could start by making a main menu, we could start by maybe drawing the scene, planning how the dungeons are going to be, how the fields are going to be. But a good point of start, if you are looking at from the code perspective, from the prototyping perspective, is to make the player, because the player is going to work as the sort of portal between the player and the game. Okay, it's the main point of entry for the player's input. So if we press keys, the player is going to move to the left, right, top, bottom. If we press the space bar, for example, the player is going to jump. So it's the first thing the player sees. Okay, so it's very interesting to start with a player. So if you look at the hierarchy, since this is a default project, we just created it, there's nothing special here. We just have two game objects. We have the main camera that renders the game, as you should know if you already work with Unity, and we have a directional light that pretty much shades the entire game. And to make a player, we need to make a new object here. In the end of this course, we're going to be integrating the final art. So there's going to be a player model with a little cute animation for walking, for attacking. But while we don't have this, while someone is working in the art in your team, you can already prototype. There's no need to wait. Okay, the game doesn't need the final art just yet. We can worry about the code, about functionality, about making the game fun. And after we do this, or while we do this, art is going to be developed by your fellow artists, or even yourself if you're going to make your own art in the end, and then you integrate it in the hierarchy. That way we can do lots of things at the same time, so an entire team can be very productive by doing this workflow. So in the hierarchy, we're going to select the untitled, which is our scene. We're going to right click on it, and we're going to select game object, and then we're going to choose 3D object, and finally we're going to choose, let me think, let's use capsule for this. Okay, So if you look at the scene, we now have a visible object. It's a capsule shape. Okay, it's three-dimensional. You can see that it is shaded by the light. And if you select the capsule, we can see a few things in the inspector. So we have the transform component that is going to define its position, rotation, and scale. We can set this to be 0, 0, 0. Right here. We have the rotation, we have scale, okay, and there are some components. We have the mesh filter, which is going to show, which is going basically to store the data for the 3D model that is being rendered here, okay, so the entire mesh for this 3D object. We have a capsule collider, which is used for, as the name suggests, processing collision, and we have a mesh render, which is the actual thing that draws this capsule for us, okay, so this is what makes us see this 3D object. And we also have a materials field that is going to define the list of materials used by our capsule. And the materials are responsible for shading the object, so adding colors, processing lighting, giving transparency, a metallic effect, wooden effect, and other things like that. But the thing is, when we're developing the game, right from the beginning, we have to worry a lot about the hierarchy. Okay, this capsule is going to be transformed into the player. We're going to face this as the player. Then there is going to be a script for the player, and that script is going to receive key input. We're going to make the player move. So sometimes, and actually most of the times, it is interesting to make a game object that is going to be the actual player, not this model here. And then we make a hierarchy inside it, so we are able to animate that player in a much easier way. So what we can do here in the hierarchy is, we right click anywhere, and we choose create empty instead of choosing any other option. So we're going to have an empty game object. If you have the moving tool selected, you can see that it's located here. And we're going to rename this game object as player. You just go to the inspector and type player up here. And we're going to select the capsule, we're going to drag it and drop inside the player game object we just selected. Okay. Now, inside the player, once again, we're going to right click, and remember to have the player focused this time. We select create empty, and this game object is going to be renamed as model or container. There are several names that can be used for this. And once again, we move the capsule inside the model. Okay, and now, if you look at the player, it's in the position, a position that is not 0, 0, 0, but let's do it right now. X is going to be 0, Y is going to be 0, and Z is going to be 0, so our player is centered. But if you notice, the capsule that we added is not here. Okay, this is the local position for the player, is the origin of the scene. But the capsule is not in the origin. If you select the model for the capsule, you're going to see that it's in the position 0, 0, 0 as well. Okay, that's fine, that's working just great. But if you select the capsule, its position is -1, -0.9, 4.8, and this position is relative to the parent. So this position is relative to the model position, which is also relative to the player. So if we want the capsule to be in the position 0, 0, 0, we need to set it to be 0, 0, 0 as well. It might seem that we're doing something very simple, maybe unnecessary at first, but as you develop the game, you're going to see how important it is that we do these things, okay? So for example, we're going to control this player game object. It's going to move like this. It's going to change its position, it's going to jump, but if you look at the model, we still have the default position, the default rotation, and the default scale, and same goes for this capsule game object. And later, what we're basically going to do is we're going to remove this capsule from here, and then we're going to add the final player model. Animation is going to be much simpler like this, okay? It's going to be really simple. Alright, so we're going to set the player to the position 0, 0, 0, and just for us to have a notion of where the player is looking at, we should make some eyes for it, okay? So inside the model, while we have this selected, we can right click, choose 3D object, then we're going to choose sphere, and if we move the sphere from the side, we're going to see this element here. So we're going to reduce its size to, let me think, 0.2 on all axes, okay, on X, Y, and Z. And if we manage to move our scene camera close to the player, and just to remind you, we can right click in the scene window and press the WASD keys to move around. We can position the eyes to be here, for example. Okay, so it's in this position, -0.24, 0.64, and -0.5. Okay, or I think it's better as 45. So we have one eye. Now we can right click on the sphere and choose duplicate, and we can change this position to the reverse of whatever we have in X. So if it's minus 0.24, we set it to positive 0.24. So we have two spheres. And now we should add a color for it, and colors for that in general. So we need to make a material in order to make this look better. So we're going to deal with the project window right now. Okay, if you look at the project window, you have the assets folder, which is going to store all the necessary files for your game. And inside this folder, we're going to use all our files. The thing is, as you make a huge game, as you work on making big games that are going to be published into the stores, you need to work on adding plugins, on adding third-party content, on adding art that you downloaded from the asset store, for example. So it tends to be messy if you don't organize things from the beginning. So my first recommendation is here in the assets folder. You should right-click, choose Create, and then you're going to choose Folder, and you're going to name this Project. Simply project, simple as that. And you might ask yourself, hey, that's kind of redundant because of course the files that are going to be here are related to the project, but as I told you, we might have other files that are not directly related to the project. They are third-party stuff. Okay, now we enter this project folder, we're going to right click and we're going to choose create and then a new folder, and this is going to be named materials. Now we're going to open the materials folder and we're going to make a few of them. We right click, choose create, then material, and I'm going to name this as eyes. And I'm going to right click again, create, material, and this is going to be named as body. So we have two materials that are going to be used for changing the colors and how our player is going to look. So we're going to start with the eyes. We're going to select it in the project window. And if you look at the inspector, we're going to see some details about this. And what we basically want to do is to change the color. We're going to click here in this white rectangle and change to whatever we want. Maybe a dark brown, for example, or completely black. Let's stick with the black color. So we just click and choose black. We can close this window. And to apply this material, there are two ways. If you are in the scene window, you can just click on the eyes material. You can drag and drop it in the eye. Okay, and it's going to look like this. The other way is you choose the game object like this one, and you go to the mesh render. You make sure that this materials field is expanded so you can see the full material. So we drag the material and drop it here. Okay, so we have these two black spheres that work as eyes for our player. And now we can select the capsule and do the same thing for the body. So if we drag the body model and we drop it here, it seems like nothing changed, but the body material is applied here. So we can also do the other way around. We can apply the model, we can select the material, choose the color picker, and then pick the color that we want. Okay, so I'm going to choose a certain tone of green, like this one, for example. Okay, and also we might tune this a little bit more, so we can change the size of the eyes to 0.3, for example. I think it's a bit better. And also let's rename a few of these objects. So the capsule is going to be body, sphere is going to be eye, and sphere 1 is going to be eye as well. There's no problem with using the same name. Okay, so with this we have our player model, and to move the player around we can simply deal with the X position. Okay, X, Y, and Z position. We can rotate it around like this, so we rotate only one game object instead of rotating all of them, just like this. And we can change the scale as well, everyone together, like this. Okay, so this is pretty much everything that we need for designing the player, and now we're going to talk about movement. To make the player move, we need to write some custom behavior for it, because so far we have elements that Unity already provide us. So for instance, we have a camera that is going to look at our player, we have a directional light above the player, we have the player itself that contains its own hierarchy, it contains a mesh render, a mesh filter, but there's nothing here about controlling the player. And the best way to do this is to make our own script. So we're going to start coding to make the player move. Okay, you don't have to worry too much about this. This is going to be very straightforward. We're going to see the exact things that we need to make the player to work. So we're going to open the project window and the project folder. We right click, choose create, then we choose folder. And we're going to name this folder as scripts, just like that. Now, after this, we enter the scripts folder. Once again, we right click, choose Create, and we're going to select C# script. Notice that we also have JavaScript, but C# script is much more common in Unity games, and it's just simply better to code because we have a more strict way to develop the game. So we select C# script, and the name of this is going to be player. Okay, very simple. After you create a script, you notice that it's going to compile because, well, if you create a new script or you edit it, it needs to compile so it converts to a format that Unity understands. But after that is finished, it's going to be okay. And before we open the player script, it's important to attach it to the player game object, okay? Because when we are developing a Java app, for example, or we use any other languages, we have to set in the project what's going to be the entry point for the code. It's a bit different in Unity because every script you make is going to change the behavior of a game object. So it's a script, okay? You're going to give instructions to something to follow. So to attach this script player to the player game object, you can either drag the script and drop it here in the player, or you can drag the script and drop it here in the inspector. Okay, and as you see, we now have a new entry in the inspector window. We see the player, we have the transform component, and we now have the player script component. So everything we write here is going to affect this game object. And now to edit the player, we can simply double click it. MonoDevelop is going to open, and we're going to be able to write the logic for the player. Okay, so we have to wait just a little bit for it to open. It's a great software, it's free, it's open source, it already comes with Unity, and it works just great. Okay, it's better than ever. And now that we are here in the player script, we need to understand two things. We have the start method and we have the update method. So for input, we need to check at all times if a key is being pressed. So right now we just have the player and we want it to move to the left or to the right. Okay, so we're going to learn how to do this by going to this script here. And in the update method, we want to do something very simple. If I want to make the player to move to the right with a fixed speed, what should I do? I can come here and type transform.position. Okay, so when I type transform, it means I'm going to access the transform component of the player. Remember, we are in this script. If we type transform, we're going to be here. And if you type transform.position, we're going to be here. So we're going to change the position of the player. So after we do this, we're going to use the equal sign to assign a new value for this position. And this new value is going to be new vector3. I'm going to open and close parentheses. And now we have to set the values for x, y, and z. Okay, there are three components, the horizontal one, the vertical one, and the depth one. For this case, for this very simple test, what I want to do is to move only in the horizontal axis. So to make it move with the horizontal axis, we can type here transform.position.x plus any number. So let's use, for example, 0.1f. Okay, so that's a number with a decimal part. It's a tenth of a unit. Okay, and the y position can be the same as it is right now. So I simply repeat transform.position.y, and the z position, the depth one, can stay the same as well. So transform.position.z. I'm going to save this. Let's go to Unity. We're going to wait for this compilation to be finished, and we're going to press the play button so the scene can be played. Okay, I pressed this. Then we're going to see our player after the loading is complete, and it's moving to the right. Okay, so exactly as expected. This is what we want. We just want it to move to the right. However, this is going to run differently in different platforms. Okay, there is a problem here. This update method is called once per frame. So every time your game is processed by your computer, by your mobile phone, your tablet, your television, smart television, watch, doesn't matter. There is always an update method that is being called, okay, at all time. If your computer is fast and it executes the game at 60 frames per second, the update method is going to be called 60 times a second. So what is going to happen here? Let me add a multi-line comment to simplify this. So what is going to happen here is, if you're going to have 60 frames per second and you move 0.1 to the right per frame, that means that after 1 second the player will have moved 6 units in the horizontal axis. Okay, so that's case 1. Now, the case 2 is, if we are running on a slow device and it's running 20 frames per second, the player still moves 0.1 to the right per frame, but the outcome is going to be different. After 1 second, the player would only have moved 2 units in the horizontal axis. So that's a huge problem. You can't be unfair to players with slower devices or to faster devices if the game requires precision and care. So we need to adjust this, and this is a very important topic in movement. We are going to change how the movement is going to work, but still this is something very important to cover. Because if this happens, well, your game is not going to work very well. So what we have to do is, there is one variable that we can use in both cases here that is going to return how many seconds have passed since the last update method call, since the last frame. So that means at 60 frames per second, I think about 0.166 seconds have passed. Okay, that's the time needed for 1 second to pass. Okay, and that is on each frame. And at 20 frames per second, that would be larger than it is right now. So that would be 0.4, I think. Okay, so that's 3 times as fast as this one. So it should be something like that. So if you multiply whatever you have here as the speed change for the player by the time that has passed, everything is going to scale accordingly. Okay, so in 1 second, since 60 frames are going to be executed here, and then after 1 second, the player is going to move the exact space as a device that runs at 20 frames per second, as long as you multiply by time.delta time. Okay, so what we're going to do is, we're going to get this, and we're going to multiply by time.delta time. Okay, and this is going to be much smaller than it is right now, so we can change it to another number like 5f, for example. And if we save this and we run this in Unity, whatever you're going to see in my screen is going to be almost the same speed as you're going to see in your computer. Either it's faster or slower. It should give the same effect. Okay. And one other tip for you about movement is you can improve this a lot. You can make this a lot shorter to write this code by using a different technique. Okay, so it's important to learn how to write short code, but that's still readable. That is going to add a lot of value to your code. It's going to be very easy to read and very easy to understand. So another way to change this is, since we are working only in the horizontal axis, we can type transform dot position plus equals, so we're going to increase another vector, and we could type here new vector 3, and we can pass 5f multiplied by time delta time 0 and 0. Okay, so it's going to be the exact same thing as this one here, but we're adding an increment. We're just adding this horizontal part. And there is even another way to do this, which is the best one in my opinion. You can simply type here vector3.right multiplied by 5f multiplied by time.delta time. This is the best thing possible that I think. Vector3.right is a constant value for 1, 0, 0, as you can see here in the summary. Okay, if you hover your mouse on the right, you're going to see that. Shorthand for writing 1, 0, 0. So you're going to move only in the horizontal axis. Okay, so we can remove this from here. Okay, we can save this, we can go back to Unity, we can wait for the compilation to be finished, and after we press play, the player is going to move in the same way as before to the right. But now that we did this, what we have to do now is to make the input for the player. Okay, so if the player presses the right key, it moves to the right. If presses the left one, it moves to the left. To make the player move, we need to call a very special method. Right now we are in the update method, so we have to check at all times if a key is being pressed. So what we can do here is type if, we're going to open and close parentheses, then open and close curly braces. This is a conditional block, so we're going to ask a question between parentheses. The question that we want to ask here is input.getKey, and between parentheses, we're going to pass the string. Okay, so let me open and close parentheses and add the 2 double quotes, and I'm going to type right. Okay, this is the code that we use for the right key, okay, the right arrow, the directional key. And if this is true, then I'm going to put this line inside here. So you can just cut that and put it here. If we press the right key, then the player moves to the right. Now we're going to save the script. Let's go to Unity. We're going to wait for the compilation to be finished. And after that, we're going to press the play button. Okay, so right now it's different than before. The player is just standing still. But if I hold the right key, then the player is moving to the right. Okay, and there's an interesting topic that we have to talk about this. Okay, we have it working perfectly. Okay, it's working just fine. But there are two different types of input, and you're going to see this different best when we make the player to jump. But still, it's good to understand about that right now. We have two different get key methods and different input methods. We have get key and we have get key down. These are two different things. At first, you might think what we should use is get key down because, hey, it's when we press the key down. But that's a bit different. If you call get key down, as you can see in the summary here in Mono, it's going to return true in the exact frame the user presses a certain button. So if I press the right key, the player would move to the right, then it would stop. I would need to release the right key and press it again to make the player move again. So you can even try that by practice. You can go back to the game after you save the script. You can test this out by pressing play. And if I press right, notice that the player is moving only a little bit. Okay, if I press right, it moves. I have to release it and press it again. And keep doing this to make the player move. That doesn't work for things that should be constant, like movement. It works good for attacking, for firing weapons, for jumping. We don't need to make the player to fly upwards, for example. Okay. So anyway, in this case, we have to use get key right. Now, to move to the left, we're going to do something very similar. So we're going to type if input.getKey and between parentheses left. Then we close parentheses, we open and close the curly braces, and we're going to write something very similar. We're going to type transform.forward.position plus equals vector3 dot, and then you could either use right here or you could just type left. Vector3 dot left multiplied by 5f multiplied by time dot delta time. And the same thing goes for moving forward and backward. So I'm going to type if input.getKey of type up, then what we're going to do is transform.position plus equals vector3.forward multiplied by 5f multiplied by time dot delta time, and finally we're going to test with the key down. So if get key down is true, then transform.position plus equals vector3 dot back multiplied by 5f multiplied by time dot delta time. Okay, so we did all of these things in here. We can save this. We can just go to Unity. Then after the code is processed, we can just press play to try this. So this is left, right, this is up, and this is down. So we are able to move our player in a certain plane, okay, in the horizontal plane. Even though we're not using the vertical axis, we are just moving the player in the horizontal plane. It's sticking to the floor, okay, so the player can move just as they want, and it's going to simply work. Okay, so that's pretty much what we needed to give the input to the player. And now that we have this, we should work on the logic for making the player jump. We're going to need to change a few things, but still that's a very good lesson to have on how this type of movement work and how we need to worry about the delta time when we're going to implement other things. So in the next lesson, let's make the jumping functionality. There are several ways to make the player jump. With the code that we wrote, we could write a logic for if we press the space key, for example, then the player would move up. But then we would have to write the logic for applying gravity to the player. Then it would move down. Then we would have to check for collisions. We would have to implement an entire physical system for making jumps and movement. And that's not very a good idea. It would work. We could write that probably in around an hour. But the best thing is to use things that are already provided by us. From time to time, you might feel the need to write your own logic, but if you are beginning, the best thing to do is to use what is provided to you. You don't need to reinvent the wheel, okay? Sometimes, of course, we need to customize a few things. It really depends on the game you're making, but in general, we should use what we have. So if we press the play button right now, the player won't fall. It won't collide with any elements that we add. Well, basically nothing special would happen. So what we have to do here is to tell Unity that we want our player to respect the laws of physics. That means that the player is going to fall, the player is going to collide with other elements, and, well, basically physics. We need to apply that. So to do this, we're going to select our player game object. Okay, so we just have the player script. And here we're going to press Add Component. And in this searching field, we're going to search for this, rigid body. After we find this, we're going to click on rigid body. And just by doing this, if we press the play button, the player is going to fall. Okay, if you look at the scene, it's just falling, it's moving faster and faster down until it disappears from the scene, okay, which is great. We already activate physics by just making a very, very simple change like this one. Alright, so now we need to add a plane for the player to collide with. And before we do this, we should go and simplify our player game object a little bit. We're going to select the body and both eyes. Okay, so to do this, you can click on the body, hold Ctrl or Command, and select the eyes. And actually, that wouldn't work. So let's go individually. We're going to choose the body, and we're going to remove the capsule collider from it. And I'm going to tell you why later. So let's remove this here. And for the eyes, you can select both because they have the same collider. And we're going to remove the sphere collider. So you go here, click on the cog, and choose Remove Component. Why are we doing this? The colliders, they are used for processing physics, but since we want to simplify how our player works to build a nice hierarchy here, we don't want the colliders to be in the graphical elements. Okay, there is no need to make things complicated and to give more things for the engine to process, to calculate. So we can just go to the player and add our own collider here in the player. So we can click on Add Component. We're going to search for a collider, and we have lots of different colliders that we can use. I'm going to use the simplest of them. I'm simply going to use Box Collider. So if you click on Box Collider, you're going to see there's a green box around our player. So it's looking like this. Okay, so now that we have this box, we want to increase its size a little bit more. So it's going to cover the entire player's body. So we're going to change this size to 1.5, I think. A little bit more, it's probably 2. Yes, 2. 2 is the exact size that we should use here for this capsule that we have. Okay, so now we have a box surrounding the player completely, and that's exactly what we want. Okay, and now that we have this box, of course, if we press play, the player is simply going to fall. It's not going to hit anything, and it's going to stay falling forever. So what we have to do is let's add a floor to this scene. And that means we need to improve our hierarchy a bit more. Okay, we have the camera, the light, the player, but we should change this a little bit to make a controller that is going to control the rules of the game. So it's going to we're basically going to tidy up this hierarchy a little bit. So we're going to right click, choose Create Empty, and I'm going to rename this game object as Game Scene. Game Scene should be just fine. I'm going to choose the player, the directional light, and the main camera, and I'm going to drag them all inside Game Scene. And I'm going to right click, choose Create Empty, and this new game object is going to be named as Level. So everything related to the level, so the floor, caves, enemies, chests, things like this, are going to be here inside the level. So in the level, I'm going to right click, choose 3D object, and this time I'm going to select the cube. This is going to serve as the floor for this game. Okay, and this cube, I'm going to change its size, so it's going to be, for instance, 20 on X, 20 on Z, and 0.1 on Y. And we might want to move the player upwards a little bit. So X is 0, Y is going to be 1, and Z is going to be 0. Actually, let's move Y to 1.2, so the player 1.5, so the player falls a little bit in the beginning of the level. It's going to be a bit difficult to see things in this white floor, so we might want to change this color as well. So I'm going to Materials folder, right click, Create Material. It's going to be a grass floor. And in the inspector window, we're going to change this color with the color picker to a tone of green that is almost bluish. Let's see how this looks like. So I'm going to drag and drop here. And, well, I think it contrasts well. Okay, maybe we want to make it a little bit lighter, like this. And yes, this should be good. So notice that the cube that we have here, let's also rename it to floor, contains a box collider, but it doesn't contain a rigid body. But that's okay, because since we have a box collider, the player is going to collide with this floor. So if we press play, the player is going to fall and it's going to stick to the floor. Okay, we can even still move like we did before, and the player only falls if we move to the side. Okay, if we move to the side, the player falls, and you can even see that it rotated because of the shape of the collider that we have here. Okay, this is a box collider, so after we are a few units to the left, it simply falls to that size. Okay, we're going to make a few adjustments as we build this, but anyway, now that we have this logic written for the physics to properly work, we can make the player jump. So we're going to work on this in the next video. To make the player jump and, well, using the physical system, we need to deal with its rigid body. So we're going to go to Mono, and in the player script, we're going to do something a bit different. Here, we're going to type if input.getKey, and passing the key space as a parameter. We're going to adjust the scope here, and to make the jump, we need to work with a thing we called force. So force is, like the name suggests, is something that is going to propel an object to a certain direction. It could be up, to the left, to the right, it could be down. In case of jumping, it's going to be up. So we need to access our rigid body. To do this, we can type getComponent of type rigid body. And notice that to set the type of the component that we want to get, we use these two characters, lesser than and greater than. And after we do this, we open and close parentheses, and we're going to use dot to access it. And you're going to see that there are a list of methods here in our interface. We're going to use add force. Okay, so as you can see, it says the parameter is the force vector in world coordinates, and it adds a force to the rigid body. Okay, and if you look, there is a signature for this force that receives directly X, Y, and Z. So we're going to use that. Okay, we have three parameters: the force in the X-axis and the horizontal, and the Y-axis, which is the vertical, and the Z-axis, which is the depth. Since we jump, the force is simply going to be upward. So we're going to type 0 on X. Let's try 50 on Y and 0 on Z. So we're going to use these three parameters. If we save this and go to Unity, we need to wait a little bit for the compilation to be finished. And we're going to press play. And if I press space, the player jumps, okay? And it jumps just a little bit. But notice that if I hold the space key, the force is always going to be added and the player is going to be propelled with a lot of force upwards. This is not what we want to do. So that's what we talked about the getKey method call. For the space, instead of using getKey, we need to use getKeyDown. So once again, we save, we go to Unity. Let's wait for the compiling for a finish, and we try that again. This time, if I press space once, the player jumps, but you notice that it jumps just a little bit. You can barely see the player jumping, just a few pixels. So there are a few ways to do this. We might keep trying here. We might try 150, compile, try, it's not good, 250, and just keep trying. However, we can do this the smart way, which is to expose this variable to the Unity editor, so we can try that here. Okay, instead of working with this script, we can simply work here directly in the Unity interface, change values while the game is running, and well, be able to test to find the best value that we want for jumping. Okay, so to do this, here in the player class, we're going to declare a new variable. So this is going to be public float and then jumping force. And let's add a semicolon here. Okay, so that's basically it. It's a public variable of a floating point number, so it's a number with a decimal part, that is named jumping force. And since it's public, it can be accessed by other classes, but better than this, if you save and go to Unity, you're going to see that that field is going to be exposed here, so we can use whatever number we want. So for instance, we can use 200, and whatever we put here is going to override whatever we set here. Okay, if we typed jumping force equals to 50 and we changed in the editor, what is in the editor is going to be used. And now that we do this, we can change this force here, instead of being 50, to jumping force. So I'm going to type jumping force. Okay, so we're going to save this, go to Unity, and we're going to try this out. Since jumping force is 200, let's see how this is going to look for the player jump. So we play, the player is going to be here. If I press space, it jumps like this. Okay, it's a decent amount, but we can increase that a little bit more. So maybe 325, and it's going to look like this. Okay, and you can even move while you're jumping. Okay, it's going to work just fine. You can still use that entire jumping force and move, because we are not changing the position in the vertical axis. We just deal with X and Z. Okay, there is no vertical component here. It's not going to affect the jumping force. But there's a problem here. Notice that if you try to jump and press space mid-air, you can keep jumping. Okay, you can just jump as much as you want. It could even be considered flying. So we need to write a logic for the player to only be able to jump when they touch the floor. Okay, so let's work on this in the next video. To avoid the player to jump while they are mid-air, we need to write a logic for locking the space key. So the jumping logic only happens if you are touching the floor. There are many different ways to do this. Okay, one way is to make some areas in the game that are going to be considered jumping areas. You might have seen this in another course. This is the beginner's way to do this, but we can go to a more advanced logic here that is going to be much tidier, but it's a bit of an advanced concept, but it's easy to understand if you practice this. Okay, so the first thing that we want to do is, in the beginning of the class definition, we're going to type private bool can jump. Okay, so what we're doing here is we're going to make a flag variable. This is going to be either true or false, because this is a Boolean variable, and it's going to be private. Okay, only the player can access this. So we're going to use can jump. What we want to do while the game is running is we're going to check at all times what is right below the player. So imagine if you look at the player, okay, you're going to see there is a green cube around it. We want to see just below this green cube. So we're going to add a little tolerance area that if this area is touching anything like the floor or an enemy or anything else, then if this is happening, then the player can jump. Okay, they can perform the jump if this happens. So to do this, we have to make what we call a ray cast. A ray cast is casting a ray, is shooting a laser beam from a certain point towards a certain direction. Okay, it's really like you're shooting a weapon. And what this raycast can do is retrieve information for us. If the raycast touches anything, if it hits anything, then we can know whatever we hit. So to start, here in the update method, okay, we are in this method, we're going to type raycast hit. Okay, so we made a local variable for this method called hit, and its type is raycast hit. So it basically returns information from a raycast, as you can see in the summary. And to perform the raycast, we can type physics.raycast, and between parentheses we're going to pass 4 parameters. The first parameter is the origin of the raycast, and that is going to be whatever the player is. So this is going to be very simple. We can simply type transform.position. Okay, that is the first parameter, where it's going to be. Now the second parameter is going to be the direction where the ray is going to move. Okay, and for this we're going to type vector3.down, as the player only jumps if they are touching something below them, not to the left, not to the right, front, back, only below. Okay, and this is interesting because transform.position is a vector3. It's a vector with 3 variables, and vector3.down is also a vector3. But the difference is this is referencing a point in space, a position, and this one is referencing a direction. So they are basically the same structure, but they have different meanings. And this one specifically contains a magnitude of 1. Okay, and what this means is this vector contains the size of 1, so we can increase its size. Okay, we can change that if we want by just multiplying it with any other numbers. Okay, the third parameter is going to be where the information from the raycast is going to be saved. It's going to be saved in a hit, so I'm going to type out hit. This out keyword is necessary because we're basically going to do something very special in C#. We're calling this method and we're going to change a value from outside this method call. This is not very common, so we use this out keyword. And the final parameter is going to be the maximum distance from this raycast call. Okay, so that's going to be the distance where the ray is going to travel. If they reach that position and they hit anything, then, well, it's not going to the ray cast is going to basically stop there. Okay, so the distance that we want to use is 1.01f. We add that little tolerance to see if the player is touching the floor. Now we can add a semicolon, and the interesting thing here is this raycast method also does something else. We have lots of parameters, we perform the raycast, we save information in the hit variable, but the last thing that this method does is return a Boolean variable. It's going to be true if we hit something or false if we didn't. So what we can do is remove the semicolon that we just added and enclose this in an if block. So we can type if, then we put the physics raycast in parameters, then we open and close the curly braces. So here, if we reach this portion of the code, it means we've hit something. If we hit, then we're going to set can jump to be true. So here I'm going to type can jump equals to true. And the catch here now is, if we press space, we need to check before if can jump is set to true. So before this, I'm going to type can jump. So if can jump is the same thing as asking if can jump equals to true. Okay. Since can jump is a Boolean variable, you can just leave it like this or type two equal signs and true. Okay. But let's leave it like this so it's simpler. And we also need to check if we are pressing space, of course. So we use the AND operator. We use these two characters here to determine that this if block is only going to be true if can jump is true, so that's in the left of this operation, and the get key down space is also true, to the right of the operation. Once we are inside here, we set can jump to false, and we have to wait for the player to fall again and hit something, so can jump is set back to true. So we can save this, go back to Unity, we can wait for the compilation to be finished, and if we press the play button, the player is going to be in the floor. If I press space, it jumps, and if I press space mid-air, it's not going to do another jump until I touch the floor again. Okay, so that's the behavior that we wanted. Okay, we only jump if we touch the floor, which is great. And what we can do now is tidy up this code a little bit. Okay, so here we might want to add some comments. Okay, comments are good because with comments we are able to write in human language whatever is happening and make it easier for us and other developers, other designers to understand what's happening. So I'm going to add two slashes and I'm going to say raycast to identify if the player can jump. And all of the other lines here, I'm going to put in a separate method that is going to be a process input, for example. So here we can type void process input, open and close parentheses and the curly braces, and we're going to copy all of these lines from here and paste it here in process input. And I'm going to cut this one for the jumping logic and put it here. Okay. So the update method is much clearer now. We just performed the raycast in here, and in the end of the update method I'm going to type process input. So we actually call the process input method and everything still works as before. Here I'm going to add a comment, so move in the XZ plane, so we don't move in the vertical plane by doing this, and here we check for jumps. So the code is much tidier now. We have the update method, the process input call, and everything is working just as we expected. Notice that if you jump, there is still a very specific case that if you press space strong enough, okay, it's very difficult to reproduce this, but if you press space very quickly and very strong enough, you can still perform a double jump. So there is a thing that we can do to adjust this. When we use the add force call, we're adding a velocity to the up vector. So if we type add force, we add a jumping force, that's fine. But if we are able to still press space again, then we're going to add the force one more time. So the velocity is going to kind of double. So what we can do here when we perform this jump, instead of using jump force, we're going to use a jumping velocity. So we can change this to this, moving, jumping velocity. And what is going to happen is instead of we call the add force method, we're going to directly change the rigid body's velocity property. So we're going to type here get component of type rigid body, we open and close parentheses, then we type dot velocity, so we're going to change it directly, equals to a new vector 3. So we open and close parentheses. The velocity on x is going to be unchanged. So we can just copy this code here, paste it here, and put .x in the end. The velocity on y is going to be the actual jumping velocity, and we add another comma, and we end with get component rigid body velocity z. So this is going to force the velocity in the vertical axis to be jumping velocity. So if we save this and go to Unity, we can wait for the compilation to be finished, and we're going to change this jumping velocity to 5 for now. We're going to press play, so we try this very easily, and if we press space, doesn't matter if we are able to land a double jump, the velocity is always going to be in a fixed value, which is going to be 5. Okay, even though that might still happen, we are safe now because we forced the velocity to be like this. And since we are using velocity, we should change also how we make the movement in the XZ plane. Instead of directly dealing with the X, Y, and Z positions, which might be dangerous if you use this rigid body logic, we want to change this. So I'm going to add here a public float moving velocity, and here in the get key right, we're going to do more or less what we did here, but this time we're going to type get component of type rigid body, we open and close parentheses dot velocity, and we're going to set the velocity in x, y, and z. Okay, so it's going to be a bit crowded here, but we're going to simplify this soon enough. So this is going to be a new vector 3. Let's open and close parentheses. The velocity on x is going to be the moving velocity that we just added. So moving velocity, this is going to be on x, y and z are going to be unchanged. So we just copy and paste these. We set y and we set z. So we just change x. All right. Now, one thing that we might do that is going to be interesting for this game, since it has an arcade logic, is we set moving velocity on x to be what we just put, and we could set z to be 0. Okay, we might want to do this if we want to make a more simplified movement, but well, let's try it like this. Okay, now we remove this transform position logic, and to save some time, we can just select this entire block that we did, we can copy it and paste here in the left part. But instead of using moving velocity, we use negative. If you move to the left, you're moving to the negative side of the horizontal axis. Now, for up and down, more or less the same thing. We can copy that, paste in the up section, and instead of minus moving velocity on x, we're going to use this on y. So it's going to look like this. Up is going to be, actually we use on z. Okay, we use moving velocity so it moves forward. And x is going to be the same as before. So let's review that. We are moving to the up, so we are going to set the velocity. The x value is going to be unchanged, y is going to be unchanged, and then we set moving velocity on z. We copy this, we paste this in the place of the down method call, and we use minus moving velocity. So this is what we need to use to set the velocity. Now we need to check if we're not pressing any of these keys, because if we are not, then we need to set the velocity to be 0. Okay, so there are multiple ways to do this. One way is to just in the beginning you can set the velocity to be 0 on x and z, and then wait for the velocities to be reset here. So we can try that as well. We can type get component of type rigid body, we open and close parenthesis dot velocity equals to a new vector 3. Then we're going to set x to be 0, y to be whatever is set here, so we can just copy this line and paste here, and z to be 0 as well, so the player should slow down. Okay, so this is everything that we have. We can save this, go back to Unity, we can wait for the compilation to be finished, and after this is done, we can set the moving velocity to be 3, for example. We can press play. The player standing still, if I press to the left, it's going to try to move to the left, but you notice that it's a bit different. Okay, the player is kind of rotating around, so we have to make some physical adjustments for this entire logic to work. Okay, so let's work on this in the next video. The reason the player tumbles, like we saw in the next video, is because we are using now the velocity. So we're using the physical system. And the physical system contains friction. Okay, so if you look at the scene and you take a close look at the player and you move the player in the game scene, you're going to see that this friction is making our rectangle shape box collider to just tumble around. Okay, so we need to make the game simple in a certain way here to avoid the player to tumble like this. So to do this, we have to go to the player, we have to go to its rigid body, and you notice there's a constraints field, so we can change a few things here. We basically want to change the rotation on X, Y, and Z, okay, to freeze that rotation. We don't want the player to rotate. We just want them to move in the position axis, okay, so X, Y, and Z, but it doesn't need to rotate. So if we press play now, we can move the player as we did before, okay, so the player moves in the position that we defined. If we release the key, then it moves back to where it was before, okay. If we even set the velocity to 10, we can move it faster, okay, but maybe 5 is going to be the best value that we're going to use. So that's the moment where you might ask yourself, okay, we are constraining the rotation, but how are we going to rotate? So that's the beauty of using this model game object. Since this game object doesn't have anything related to physics or with collision, if the player moves to the left, we can simply change its rotation to 90, for example, or 180, so it looks to this position. We can change to whatever rotation we want to make the player face different places. Okay, so let's stop the scene, and in the player, let's set the moving velocity back to 5. Okay, so this is what we have right now, and notice that we have lots of get component calls here, and this is a bit dangerous. This is dangerous because get component is a process that takes some time. There are two methods that are you need to be very careful about. Get component and find. They are very expensive resource-wise because you have to search your scene and your game objects for things inside them. So instead of calling get component that amount of time, we can save it here in the start method. So we can make a private variable, so private rigid body, rigid body, and call this as player rigid body. We can set it like this. In the start method, we type player rigid body equals to get component of type rigid body, and now the rigid body is saved here. Instead of calling several times, we just call this once. Okay, so here we can replace all the occurrences of get component rigid body to simply player rigid body. Okay, we can even replace this one. So we're basically going to replace things here, so we don't have to make this a very heavy code. And the thing is, this works in the update method, and the update method is called every time, so that would be very intensive. You have to think about things like this if you're working on low-end devices or mobile platforms. While this might run good on a computer or in a console, it might not work good in a mobile device like a smartphone, for example. So something to keep in mind. Okay, so we save these like this. Okay, there we go. And now that we have this, we can try this out. We can save this. We can go to Unity. We wait for the compilation to be complete. And after that, we can simply press the play button, and we are still able to move around. We still deal with the velocity, and the player is well, basically moving as expected. Now that we are able to make the player to move around, we should make the player to be able to look. Okay, and that's going to be very simple because we have this model game object that we created in the beginning of this course. So we're going to our code, and we're going to make another public variable here. So we're going to type public game object model. And a good thing to do here is we are making quite some lots of public variables, so it's interesting to make it easier to read in the Unity editor. So what we want to do is you can open and close brackets, type header, open and close parentheses, and then type the string visuals. And here we can do something very similar. We're going to type header and type movement, for example. Okay, so in the code it changes absolutely nothing, but if you go to Unity and you look at the player game object, you wait for a little bit, it's better to read now. We have this visuals label in bold movement, and we can see that our variables are now grouped. So if you look at the model, it says none, right here. So we're going to drag this model game object and drop here. Okay, so try that again here. There we go, we have a reference to the model. And now we can rotate this depending on where we are looking. If we are looking at the camera, it's going to be 0. If we move to the left, 90. If we move up or forward, 180. And if we move to the right, 270. Okay, so we need to find a way to do this. If you go to mono and you look at the right key, we can type this: model.transform.local Euler angles equal to a new vector 3. So x is going to be 0, y is going to be 270, and z is going to be 0. So what we're doing is basically rotating it by using Euler angles, which are numbers that vary from 0 to 360. There are other ways to do this, but it's one technique to make this rotation logic. If we look to the left, we can simply copy and paste this and change the rotation to 90, like this. If we look up, we can change the rotation to 180, like this. And if we look down, we can once again change this rotation to 0. So if we save this and we try this on Unity, we can wait for the compilation to be complete. We can press the play button. Okay, so the player is here, I'm moving to this direction. If I look to the left, the eyes point to the left, right, and then down. Okay, so the eyes are following whatever we are looking correctly. But you notice that the rotation is a bit rough. Okay, it's very quick, it's not beautiful. So it's interesting to change how this rotation is looking. So there's a way to make this smooth. Okay, and we're going to use another technique. This is what we're going to do. When we press right, we're going to type this: model.transform.rotation equals to. Now notice something. Rotation is not a vector 3. Okay, it's a quaternion. Quaternion is a structure that basically tells information about rotations and angles in general. It's much more difficult to understand mathematically speaking, but it's the one that works the best. If you just use Euler angles, there might be some situations in games that you develop, like space games, where the rotation is going to simply be weird. Okay, we might have what we call a gimbal lock, where a degree of freedom locks and you can't rotate anymore, or there are going to be some stutters, some approximation problems. So it's better to deal with quaternions. But doing this easy way is simply typing this, then we type quaternion.lerp. We're going to make a linear interpolation between one rotation and another rotation with a certain speed. So the first rotation that is going to be taken into account is whatever the model is. So we type model.transform.rotation. Do that again. The second parameter is the target rotation. So it's this 270 angle that we want to get. But I just told you that we're using quaternions, not Euler angles. But we can do a conversion between one and the other. So we can type here quaternion.Euler. And between parentheses we pass 0, 270, and 0. The third parameter for this lerp call is the time component. So we can simply type time.delta time, and we can multiply this by a number to make the player rotate quicker. So we can make a variable for this. So I'm going to type here in visuals public float rotation or rotating speed, and I'm going to default that as 2. Okay, and let's go back to where we were here in the right. We're going to multiply that time.delta time by rotating speed. Okay, so we can close parentheses, add a semicolon, and we can get rid of the Euler angles line that we added. Okay, so we have this big rotation call that we have here. Now we're going to copy and paste this from here to here in left. So this one is going to be 90. Okay, in up, this is going to be 180. So we simply replace the numbers. And in down, it's going to be 0. Okay, so we change 270 to 0. So this is how it's going to look like. Let's try this. We're going to Unity, we wait for the compilation to be finished, and after this is done, we can press play. If I move to the left, then the player smoothly looks to whatever we are looking. But notice something. If you stop moving, the player is going to stop in whatever direction they were looking at. This is good depending on the results that you want to achieve, but it might not be that good, okay? That might be a problem to how you develop your gameplay. So you might choose to leave it like this, okay? The model is going to rotate. However, we might want to lock in these angles. So we need to make something a bit different here. We need to define a new variable that is going to be private quaternion and then target model rotation. Okay, so this is going to keep track of what's the target rotation that we want to use. In the start method, we want to default this target model rotation to be quaternion.Euler, and that is going to be 0, 0, 0, okay, pointing to the camera. That is going to be the target model rotation. In the update method, here, we can even make this happen before the process input. We're going to type what we did here. So we can copy this line, we can paste it here. So we have model.transform.rotation equals to quaternion.lerp, then the original model position. And instead of writing this, we type target model rotation. Okay, so what is going to rotate our model is going to be this line here. Okay, only this one. And in the other ones that we have, what we need to type is target model rotation equals to, and then the Euler angles that we defined here. Okay, so it's going to look like this. When we press the right key, the target model rotation is going to be quaternion.Euler 0, 270, 0. Now we replace everything again. Left is going to be 90. Up is going to be 180. And finally down is going to be 0. Okay, just like the initial value. Now if we save this, and we'll go to Unity and we wait for the compilation to be finished, we can press play and try this out. So we press play, we have the player here. I'm going to move here. If I simply touch the left, it's going to rotate there. If I simply touch right, it's going to rotate there. So we have a target variable that the player is automatically going to rotate to, so it reaches. Okay, and if I want to increase the speed, I can simply select the player and change the rotating speed to 5, for example. So it rotates much faster as before, and it makes that interpolation. So if we press play, we're going to lose this rotating speed value because we were in playing mode, but we can set it back here. Okay, so you notice there are several ways to do several things like movement, jumping, rotation. It's interesting to cover how all of these things work because you can see what are the weapons that you can use to develop the game the way you want. Okay, so making a game is an iterative process. We keep improving, we keep building that. So all of the things that we do, we might revisit in the future to make it better. Okay, that's just the natural process of developing games. After you're done with all of these things, notice that you have a game scene, we have a player, a level, a floor, we have scripts attached. All of this information is in a scene. Right now it's untitled, it's not saved. So to save this, we can hit File, select Save Scene, and we can save this as level 1. Okay, we can press Enter to save it. It's going to be in our Assets folder, but let's make a new folder in Project. I'm going to right click here, choose Create Folder. I'm going to rename this as Scenes. And from the Assets folder, I'm going to move this scene file here to this scenes folder. So it's going to be right here. So our scene is safe. All of our information is now saved here. We have our code. So we should be able to move on to improving the game.
Hey everyone, thanks for watching this course. If you want to watch the rest of the course, the link is down below. Not only do we get the access to this course, but you'll get access to a lot of other courses in a huge bundle, and it's on sale today. So buy it before the sale ends. Thanks for watching, and I'll see you in another video.